Hi, everybody. Brad Truax here from Eastman's Woodlands and Wildlife Committee. And today we're going to talk about the trees at Eastman. Uh, Trees and forests are the heart and soul of Eastman. Eastman's founders designed the community to live within the natural beauty and the features of the land. And that obviously includes the trees and the forest. And our trees don't just provide us with shades, they actually provide life. They provide roosting and nesting habitats for both birds and many mammals. The wood, branches, leaves, nuts, and seeds provide food for many wildlife species. And you may not recognize the millions of caterpillars that feast on our tree leaves and in turn become prime food sources for fledgling birds. Woodpeckers feast upon the insects that are within many dying trees, and the trees provide shelter from the elements for many wildlife species. Trees are also carbon sinks that fight global warming and climate change. And even in death, trees provide new life to emerge. So, in a word, trees are Eastman. So again, this presentation is going to focus primarily on individual tree species, and we recommend that you go to our presentation on forest basics to learn more about the ecology of forests. And there are probably over 50 different tree species here at Eastman, but we're going to just focus on a few that are very common and describe their value for various wildlife species. So Eastman's forests are mixed hardwood conifer forests, and the distribution of trees by type is not uniform here at Eastman. Type of tree depends on location. For example, shade intolerant trees like birch need to grow where they get the most sunlight. So we'll see them in areas adjacent to open fields or adjacent to streams, lakes, or the wetlands. And in terms of forest succession, Eastman's forests are very mature. Eastman's forests provide a great habitat for a wide variety of wildlife species, but there are many threats to our trees and our forests. Invasive insects and other diseases threaten many of our trees, and climate change will also have an impact. So trees that are common here at Eastman, white pine, eastern hemlock, American beech, red and white oak, sugar maple and red maple, white ash, spruce, balsam fir, white birch, yellow birch, black cherry, and obviously many others. Uh, uh, just to give you an example that the trees are different in various locations here, this is just showing the distribution of tree species type in Heath Forest and compare that to Upper Johns Glen. So there's significant differences between them. There's several things that we look at when we try to identify a tree. We look, does it have leaves or needles? Basically, is it deciduous or a conifer? We look at the branch pattern. Does it have an opposite branching pattern or an alternate branching pattern? We look at the leaf pattern. Is the leaf pattern, are they simple leaves or compound leaves? Similarly, if they're needles, do we look at the pattern of the needles? And we look at the stem characteristics and the petioles. Are they round or are they flat? And we look at the bark. Sometimes the bark is the only thing that really distinguishes various trees. And then ultimately, we look at blossoms, fruits, seeds, and nuts that are produced by the tree. And you can use a tree identification key that asks you several simple questions and leads you to correct tree identification. And such keys are readily available online or for purchase. Dode Gladers, who is our Sullivan County forester, has put together a simple key for identifying trees at Eastman. And this is it. You can take your time with this in the accompanying PowerPoint that will accompany this presentation. And again, this is Dode Glader's tree identification tree. So basically, you ask yourself a few questions, then you go on to the next, the next, the next, and so on until you've actually identified the tree. Location, location, location. That's not just for real estate agents. Where you are can also help you identify trees. So shade intolerant trees like birch and aspen need to grow where they might get the most sunlight. So again, we'll tend to see those adjacent to open fields or adjacent to streams, lakes, or wetlands. Shade-tolerant trees like hemlock, spruce, and sugar maple tend to grow under tall canopies that block out much of the sunlight. And moist bog-like areas are very good for species like hemlock that have a high moisture requirement. And pioneer species like birch, aspen, and black cherry are likely to be seen in areas where natural disasters have recently occurred and have removed thick canopies. So again, there's several apps that are available for your smartphone that can help you identify trees as well as other plants. And some of those are iNaturalist, Seek, which comes from iNaturalist, PlantNet, PlantSnap, LeafSnap, and Picture This. But if you have an iPhone has a powerful visual lookup function, and I'll show you that in just a minute. So again, this powerful iPhone feature called Visual Lookup helps you not only identify trees and plants, but also bugs, animals, and many other things. So basically, you take a photo, and then at the bottom of the photo, you'll see this little thing. It's a little eye surrounded by a circle and a plus sign. This is what it looks like blown up. And when you click on that or press on that, Apple will tell you what it thinks you're looking at in that photograph. And it's surprisingly accurate. Okay, so when we're trying to identify it, first thing we looked at, does it have leaves or does it have needles? Okay, the top obviously leaves, the bottom needles. Then we look at the branch pattern or the bud pattern. And again, we want to know, is it an opposite branching pattern, like this one at the top, where they're directly across from each other, both the branches and the buds. And down here is an alternate branching pattern, where they come off one here, then another one further up, and so on. And we use a mnemonic, the opposite branching mnemonic, which is Mad Horse. Okay, Mad Horse stands for maple, ash, dogwood, and horse chestnut. Okay, pretty simple. So again, if there's an opposite branching pattern, it really narrows down your choices to roughly 4 individual tree species. And the alternate branches or budding pattern basically applies to all the other trees. Okay, when we look at the leaves, we look to see if it has a simple pattern or a compound pattern. So here's a simple leaf, here's a compound leaf. So again, simple versus compound. Once again, top example, maple leaves, which again are simple, versus white ash, which is a compound. And we also look at the petioles. That's the stalk that joins the blade to the node, where there's an attachment point on the stem. And again, petioles usually are round, but on aspens, they're flat. And that accounts for why aspen leaves tend to flutter in the wind. You've heard about quaking aspens. Well, it's because they have flat petioles and allow them to flap in the wind. So again, here we go. First, we're going to do the deciduous trees, then the conifers, and then we might even do a few shrubs that, if they get big enough, actually look like trees. So first, the deciduous trees. White ash is a really majestic tree. It's one of the most majestic trees that we'll see here. There are actually 13 species of ash trees. And while there might be some black ash or green ash here at Eastman, white ash is really our most common ash species. And we identify white ash by its opposite branching pattern, its leaf pattern, and its bark. And these beautiful trees can grow as tall as 120 feet, though most of them are in the 35 to 75 foot range. And their canopies provide very, very beautiful shade. Wood of white ash is very tough and strong and elastic, and it's been used for millions of baseball bats, tool handles, guitars, staircases, and other things. Black ash has long been used by Native Americans to make things like baskets, canoes, snowshoes, axes, and chairs. Unfortunately, all species of ash are susceptible to the emerald ash borer, except for mountain ash, which is actually not an ash species. So again, here's the big canopy of white ash. Again, provides lots of shade. The distribution of white ash at Eastman varies very widely. A number of years ago, we were helping people identify their ash trees in view of the emerald ash borer infestation. And in some lots on the west side of Eastman Lake, we found as many as 40 to 50 mature ash trees. On the other hand, on the east side of the lake, we found no mature ash trees and only a few saplings. So again, the distribution of white ash varies considerably depending upon where you are. So how do you recognize an ash tree? First of all, the large canopy, the opposite branching pattern. Remember that mnemonic, mad horse, maple ash, dogwood, horse chestnut. The bark tends to be smooth when it's young, but it roughens with age and takes on a diamond shape. And the leaf pattern, again, is compound with 5 to 7 leaflets per leaf. So again, once again, here's the opposite branching pattern. And again, the buds also have this opposite pattern. If you just saw the buds here, they're opposite. So particularly in winter, you may see that. And the ash leaves, again, are a compound pattern with 5 to 7 leaflets. Here you have 7 leaflets. And the bark takes on this diamond shape. So if you look closely, you'll see a kind of a diamond shape here. This is a close-up, once again, showing a diamond shape to the bark. And ash trees benefit wildlife in a variety of ways. They tend to lack tannins, which makes them both palatable and safe for many species that are feeding on the branches and leaves off the ash trees. Frogs especially rely on ash leaves that have fallen into ponds because of that low tannin content. And there are many insects that are fond of ash trees, beetles and caterpillars and aphids, and unfortunately, the emerald ash borer. Many bird species nest in ash trees. White-tailed deer browse on ash trees, and meadow voles may eat the seeds from the ash trees. Unfortunately, we've had the emerald ash borer infestation. And again, this is showing the emerald ash borer, which is a tiny invasive beetle. It originated in Asia. It was probably brought to the United States and North America in wooden packing materials and attacks true ash trees. So white ash, black ash, green ash, blue ash, which is less common here, but doesn't attack mountain ash because mountain ash is actually not a true ash tree. And once again, the spread of the emerald ash borer largely occurred through people bringing firewood from infected ash trees. And it totally wipes out ash trees from forests and communities. And again, what's at risk? To put it in perspective, Dutch elm disease, which occurred back in the 1980s, wiped out 75% of about 77 million ash trees. Chestnut blight wiped out 4 billion chestnut trees here in North America. And emerald ash borer is putting 8 billion ash trees at risk. So it's going to be a significant thing. So how do we recognize it? Well, we're well into the emerald ash borer infestation of our ash trees here at Eastman, and many will soon die. And how do we recognize trees that are affected? Well, first of all, only ash trees are affected. We look for blonding. We look for D-shaped exit holes. We look for feeding galleries. Woodpeckers may be an early sign because they can detect the emerald ash borer under the bark and are actively seeking them. And epicormic sprouts, and I'll show you examples of all of these. You may want to look at our separate presentation on the emerald ash borer, which is on the Eastman web portal. Okay, this is showing blonding. So you see this light discoloration, that's called blonding. And again, you see it both in trunk and branches. Once again, here it's a little more obvious. We look at these galleries, these little S-shaped kind of feeding galleries. Really, the only invasive species that produces this is the emerald ash borer. Here's a D-shaped exit hole. So this is where the mature beetle came out, exited through the bark, and left this D-shaped exit hole. Once again, woodpeckers can detect their presence very early. So if you all of a sudden see lots of woodpeckers around, it may mean that you have emerald ash borer infestation. And epicormic sprouts are growths that occur from buds that are underneath the bark, either in the trunk or in branches or in stems of a plant or tree. And epicormic sprouts on either the trunk or large branches of a ash tree may be signs of damage that's due to the emerald ash borer. So again, once you have identified a tree that's infected with emerald ash borer, what are the management strategies? One is to do nothing, and that's okay if the ash trees are out in the forest and not in danger of falling on humans or on property. You just let them die. But again, if it's near your house where it might fall on either a person or your property, you can either cut them down or you can treat them biennially every other year with an insecticide. It costs about $150 to $200 per tree. And that's okay for trees that have special value. So if you have trees that are providing good shade or beauty, that's definitely an option. And Eastman is now several years into the emerald ash borer infestation, and many trees are beginning to die. One reason that you might decide to treat them also is that we're still very hopeful that we may have a solution to emerald ash borer sometime down the line. So again, once again, we have a separate slide presentation on the Eastman web portal on emerald ash borer, and you may want to look at that for details. Maple trees are another species that gives rise to great beauty here at Eastman, and there are really over 100 maple species worldwide. But at Eastman, we have mainly sugar maples and red maples. And the sugar maples are taller than the red maples. Sugar maples may be up to 100 feet tall. And both are good shade trees, and both contribute to our very colorful autumn foliage. And many types of caterpillars chew on the leaves of maple trees. And that's important because the caterpillars, in turn, become a great food source for young birds. And the bark also of maple trees also harbors many insects that are good food sources for woodpeckers and other birds. And the seeds and flowers may be eaten by many birds, by rodents, raccoons, rabbits, and even bears. And deer may eat the leaves and small twigs, particularly as the maple trees are first growing. And beavers eat the wood, and they can use some of the wood to help build their lodges and dams. So again, several things help us identify a maple tree. First is that branching pattern, which again is an opposite pattern. Remember the mnemonic: mad horse, maple, ash, dogwood, and horse chestnut. And the leaf pattern of maple trees is simple, and the bark is very variable. Again, here's the leaf pattern. The sugar maple tends to have 5 lobes, 1, 2, 3, 4, 5, and shallow U-shaped notches, whereas the red maple, which is down here, has only 3 distinctive lobes, 1, 2, 3, very pointed, and the notches tend to be more sharp, so tend to have a V shape as opposed to the U shape, which is up here. And the stems typically are red. So the leaf pattern may help us differentiate sugar maple from red maple. Bark isn't particularly helpful at differentiating. Again, they can have all these 4 patterns of bark, so I don't find them particularly useful in distinguishing one type of maple tree from another. Maple seeds, the maple trees drop their seeds toward the end of spring. You've all seen these. And we often call these either helicopters, spinners, whirlybirds, or samaras. And again, they consist of 2 conjoined wings surrounding a seed. Maples in fall foliage. Maples are a big contributor to the beautiful fall colors that we see here at Eastman in the fall. And red maples are often also known as swamp maples, and they tend to turn red the earliest in the fall. So if you're driving along Route 89 and you look at some of the very low-lying areas, kind of swampy areas, the first signs of fall that we see are the red maples, also known as swamp maples. Maple sap usually begins running in mid to late February, though climate change has really it caused some of the sap to flow earlier. And you need warmer days and cold nights to get the sap running. Sap flows typically when the temperature is still below freezing at night, but in the 30s and 40s during the daytime. And you might see tiny icicles on the tip of the sugar maple twigs as a signal that flow has actually started. And the sap is then converted to maple syrup. And New Hampshire is actually the third leading producer of maple syrup after Vermont and Maine. So sugar maples are good for wildlife. Squirrels and chipmunks and white-footed mice eat the samaras, which are the seeds. White-tailed deer browse on the twigs and the buds. Yellow-bellied sapsuckers drill holes in the maples and extract the sap and eat the insects that are within them. And many species eat the cambium. Humans love the sap and the maple syrup. Okay, so that's maple trees. Oak trees are very important here at Eastman. Several things help us identify oak trees. The branch pattern is alternate as opposed to opposite that we saw with the maples and the ash trees. The leaf pattern is simple with 5 or 6 deep notched lobes and short stalks. The bark is smooth when they're young, becomes fissured with fissured platelets in mature trees, and the leaves may be marcescent in fall and winter. And what that means is that the leaves are often maintained well into winter. They become yellow. Obviously, acorns help us identify oak trees. And the acorns are extremely important. They're a form of hard mast that's an important food source for many wildlife species. You can see our separate presentation on the hard mast for a detailed discussion of acorns. So here are some oak branches. Once again, they have an alternating pattern. And this winter twig is smooth and silvery brown and has clusters of buds that are concentrated, particularly out here at the tips of the trees. Here are the typical oak leaves. So they're longer than they are wide. So here's the length compared to the width. And they have 5 or 6 deep rounded lobes and very short stalks. And the leaves first emerge in mid-May, and then they turn yellow-brown in autumn. And some oaks keep their leaves in winter. That's what we call marcescence. So again, the acorns are the nuts that are produced by oak trees. And again, they're a key source of food for multiple wildlife species in the fall. And acorn production is cyclical, and that has extremely important implications for wildlife. We'll talk about that in a minute. So again, red oak versus white oak. The white oaks have soft, rounded edges on their leaves compared to the red oak, which tends to be more pointy. And the white oaks tend to have a rougher bark. And the white oaks also grow more slowly, but become much bigger than the red oaks. And the acorns of the red oaks tend to be a little bit more elongated or ovoid, and they tend to mature every 2 years compared to every 1 year for the white oak acorns. So is the mighty oak a keystone species? Well, it certainly is. A keystone, if you remember, is basically a wedge-shaped block that holds up an arch. And if you remove the keystone, the whole structure crumbles. So again, the analogy applies to ecological systems as well. And the changes to a keystone species affect a much broader ecology. And there are multiple examples of biological keystones: beavers anywhere, salmon in Alaska, elephants in the savanna in Africa, wolves in Yellowstone. So is the oak a keystone species? No, no question. It absolutely is. So oak trees are definitely a keystone species because they're critical for the ecology of the forest and all our wildlife. An oak tree can live for hundreds of years and can produce about 3 million acorns over that lifetime. And those acorns provide essential food for dozens of bird species like jays, woodpeckers, and turkeys, also for bears, deers, raccoons, opossums, squirrels, mice, insects like weevils. And the oak leaves feed caterpillars of over 500 species of moths and butterflies. And remember, in turn, those caterpillars can serve as food sources for young birds. Oaks are also very important for things like building ships, homes, and furniture. There's also a trophic cascade. This is very interesting. So again, an acorn grows into an oak tree. The oak tree grows and then it sheds acorns. The acorn falls to the ground. An acorn weevil finds an acorn on the ground, drills a hole in it, and removes the insides from the acorn. Well, acorn ants then move into the hollow acorn and they propagate. And those ants then live on various plants aside from aphids. And the aphids feed on the sap of the plants and secrete a liquid known as honeydew, has a very high sugar content. And the ants are drawn to that sugar-rich honeydew, and they harvest it as a food source. And in return, the ants protect the aphids from predators like ladybugs. But ultimately, the harvester butterfly larvae feed on the aphids. And then ultimately, the harvester butterfly emerges from that caterpillar. So it's quite a journey from an acorn to a butterfly. That's known as a trophic cascade. And this slide actually happens to show all of them. Here are the aphids. They secrete honeydew, which attracts these ants. These are the ants that are there. They're protecting the aphids from ladybugs. But here's the larva of the harvester butterfly, and they're actually going to eat the aphids. And then ultimately, this larvae will turn into a harvester butterfly. So acorns, as we said before and multiple times, are critical food sources. The acorns obviously come from the oak trees, and the acorns contain very large amounts of protein, carbohydrates, and fats. So they're especially good choices of food sources for wildlife, particularly as those wildlife are preparing for winter. So remember, the oak trees produce most of the acorns in the fall, and that's the time that the wildlife are preparing for winter. So acorns are also good sources of minerals like calcium, phosphorus, and potassium, and some vitamins like niacin. And the total energy content of acorns does vary by species, but all compare quite well compared to most of the other wild foods and nuts that are available in the forest. But acorns also contain tannins, which are bitter and can have unwanted side effects for many animals. So some animals prefer the sweeter white oak acorns, which tend to have lower tannin content than the red acorns. Some animals, like squirrels and jays, cache the acorns. They may wait for groundwater to percolate through the acorns, which removes some of the tannins before they actually eat those acorns. And different squirrel species cache differently. The red squirrels tend to have a single cache, whereas gray squirrels tend to have multiple caches. Acorns are too heavy to be dispersed by wind, so it's really dispersal of the seeds by squirrels and jays that lead to new oaks. And when squirrels and jays are caching acorns, some of them get lost, and those lost acorns can germinate and lead to development of new oaks. And actually, many of the cached acorns never get found by the squirrels or by the jays, and they may eventually sprout into oak trees. A key concept is that acorn production is cyclical. It varies from year to year in a boom and bust cycle. So white oak trees produce acorns 4 out of every 5 years. Red oaks tend to produce acorns every other year, and it may take 2 years for those nuts to mature. So it leads to big acorn crops roughly every 4 to 10 years. And some view this cyclical nature as an evolutionary asset. Think about that. Uh, when they produce few acorns, the population of squirrels and mice and so on that eat those acorns is going to drop off the next year. So the next year, the trees can flood the area with acorns, and there are not enough animals around to eat them all. So the likelihood that some are going to create new seedlings is actually increased. So that's the evolutionary theory of why acorn production is cyclical. And the effect of those boom and bust cycles is felt throughout the wildlife community. When they produce few acorns, the population of squirrels, mice, voles, and other small animals is going to be smaller the next year. But that also means that animals like the red fox and owls that rely on those smaller animals as food sources is also going to be affected. So the red fox population is going to be smaller until the population of squirrels and mice increases again. So we tend to see cyclical nature for particularly the red fox population. And during the boom year, there are going to be more mice and squirrels and voles around. So we'll see an increase in raptors like owls and other predators. And a boom year also has consequences for humans. The number of white-footed mice will increase, and that means that the tick population will also increase because they feed on the white-footed mice. And more ticks means more ticks carrying Lyme disease, which in turn means there's going to be an increase in Lyme disease in humans. When the cycles collide, again, it's not only oak trees and acorns that have a cyclical nature. Beech trees also produce beech nuts every other year. And since they produce every other year, and the white oak produces acorns roughly every 4 to 5 years, that means that there's going to be a time, roughly every 8 to 12 years, where there's a dearth of both acorns and beech nuts. And again, that's going to be a critical time for wildlife that rely on both acorns and beech nuts as a food source before the impending winter. So such an overlap occurred here in the fall of 2018 and the winter of 2019. It was called Squirrel-mageddon because there were so few squirrels left around. And much moreover, in those doubly down years, the food source for bears dries up. And as a result, the bears start hunting in human occupied areas for food. Some of our significant increase in human bear interactions in 2022 was likely due to that dearth of hard mast in the forest. So that was a year that both the beech trees, the beech nuts, and the acorns were at a low. And the bears had to go looking for food elsewhere. Where are they going to look? In our backyards, in our bird feeders, in our garages. So again, much of that 2022 increase in bear interaction was due to that dearth. 2022 was a year that had off-year cycles for both acorns and beech nuts. And once again, since those are our primary sources for food sources for bears, they started coming to look for food in our backyards. So what's happened after 2022? Well, in the fall of 2022, the bear encounters peaked here at Eastman. In the fall of 2023 and through 2024 and early 2025, we've actually had fewer bear encounters. And so what happened? Well, Eastman's board did pass some measures that included not feeding bears, bringing bird feeders in, and securing trash and grills. That undoubtedly had an important effect. But probably most importantly, the hard mass cycle changed so that now all of a sudden, whereas 2022 was a bust year for acorns and beech nuts, 2023 was a boom year or a mast year. So the bears' favorite food in the fall was much more plentiful in the forest, and they didn't have the need to forage around humans. Unfortunately, there are a few bears that learned some bad habits and passed them on to their cubs. So we still see some human bear interactions. Okay, I mentioned beech trees. Beech trees are also extremely important. They're long-lived trees. They can live as long as 300 to 500 years. They're very shade tolerant. They have a broad crown. Their roots produce shoots. The beech nuts are, again, are a very important food source for wildlife. Several things help us identify the beech trees. Again, the branch pattern or the bud pattern is alternate. The leaf pattern is simple, the bark is smooth, and the leaves become marcescent in the fall and winter, and they produce beech nuts. Again, beech nuts are a form of hard mass that's an extremely important food source for many wildlife species. So here are the leaves, simple pattern to the leaves. They have kind of a leathery feel. They're slightly serrated, very, very fine teeth. And again, beech leaves turn yellow or tan or brown in the fall, and they often remain on the trees through the fall and winter. That's called marcescence. Marcescence, again, is when trees maintain their leaves throughout the winter. And there are only a few species that do this, particularly beech, oak, witch hazel, hornbeam, and hop hornbeam. So if you're out in our forest during the winter and you see leaves that are still on trees, it's probably one of these five species. And younger trees are much more likely to be affected than the older trees. And a good clue, they provide a very good clue to identification of trees in winter. So again, the top is showing some marcescent oak leaves. The bottom is showing marcescent witch hazel leaves. So why do some trees not drop all their leaves in fall? Well, no one knows for sure, but there are multiple theories. Some say that it leads to better leaf composting, particularly in the spring, or it leads to better soil conditions over the whole course of a growing season. Some say it helps trees accumulate a deeper snowpack, providing a source for water from snowmelt at the start of the growing season. And some say it protects new buds from being eaten by browsing fauna during winter. That's probably the best guess. So again, in the wintertime, if you have these leaves on the trees, which are not particularly nourishing, you'll see browsers like white-tailed deer less likely to eat those trees. And then there's this myth or fact. Well, back in the Ice Age, giant ground sloths were 20 feet tall. And that's right about the typical height where marcescence stops. So if you look at the trees that are maintaining the leaves in the fall and the winter, they tend to be 20 feet or less. Up higher, you don't tend to see the leaves maintained. And some people say that goes all the way back to the Ice Age when you had these giant ground sloths around. So beech bark, beeches tend to have smooth gray bark, often with some horizontal etchings on them. And many beech trees in New England, unfortunately, have developed beech bark disease. This is showing beech bark disease, and it's caused by a combination of an insect and two pathogenic fungi. And it causes waxy patches and fuzzy bumps on the bark. And it kills the beech trees, but only very slowly. So many of our trees exhibit beech bark disease, but they're still very living and thriving beech trees. Often the beech bark disease produces severe cankers. These are evidence of cankers. And in the fall, you may see the fruiting bodies of the fungus appear in the bark. This is what they look like, kind of a reddish appearance from the fungi that are in these cankers. We talked about beech nuts as being very important. This is what beech nuts look like. And once again, they fall from the beech trees in autumn, and they have a very rich oil content. And in addition to the fat content of almost 40%, they have many minerals like iron and zinc. So they're a very nutrient dense food source for bears in particular, but also for white-tailed deer, wild turkey, ruffed grouse, wood ducks, woodpeckers, and more than a dozen other species of mammals and birds. And they often have a bitter taste that's due to the tannins and a toxin called phagin. And like acorns, beech nuts do have that cyclical pattern, and they produce beech nuts every other year, which is shorter than the cycles for white oak trees producing acorns. And once about every 10 to 12 years, the bust years for both beech nuts and acorns coincides, again, creating a crisis for many wildlife species that depend on both acorns and beech nuts. There's an interesting correlation between beech nuts and bears. As we said, beech nuts are a favorite food source for bears, and they have about twice as much protein and calories per edible portion as acorns do. And there's a pattern of synchrony between beech nuts and bear cub production. So again, on alternating years when the beech nuts are scarce, the young female bears that were near breeding age would not be as fat going into the den, so they don't give rise to birthing cubs. But as a result, in alternate years with nut-rich conditions, we'll see uh, litters that produce bear cubs. so, so again, a good beech nut year means fatter moms going into the dens, and they're much more likely to produce bear cubs. So there's a synchrony between the two. So most of the cubs are born in a winter following a good beech nut year. May sound like trivia, but it's particularly important. So there are threats to our beech trees. We already mentioned beech bark disease, but that's been around for many years and doesn't kill very many beech trees. But on the other hand, the beech leaf disease, which is caused by a roundworm, does kill the beech trees. And beech leaf disease has just recently arrived in New England, and this could lead to a critical loss of food source for many wildlife in upcoming years. This is showing beech leaf disease. Again, it's different from beech bark disease. It's caused by a nematode, a small roundworm. It was first noted in Ohio in 2012. It probably originated in Japan, where it was carried here in ornamental plants. The beech trees in Japan are not affected. But in highly infested areas here in the North America, it can kill up to 90% of the young trees in 2 to 5 years. So it spreads at almost an unprecedented rate. And this tiny worm can also be blown in aerosolized droplets on a windy day, or it might be carried on the feet of birds. So it's a real threat to our forests. And in turn, that would threaten the food source for over 40 wildlife species, particularly bears that rely on beech nuts as a rich food source. So again, it's caused by a roundworm. It causes this dark banding of the beech leaves. Okay, but as the disease progresses, the leaves tend to become more leathery, and those bands tend to take on a yellow color, and eventually these leaves will fall off. And this is just showing in the bands, you can actually see the nematode or the roundworm. So beech leaf disease is a real threat to our forests and wildlife. Researchers are looking at ways to combat this disease. The potassium phosphate is good treatment, but it's not very practical economically to treat all the beech trees. Aspirin and methyl salicylate, which is found in wintergreen, is showing some promise. And European beech trees are not susceptible to this disease, so they may ultimately become a good alternative one day to replace the nut production if we do lose these American beech trees. Okay, another species that's common here is black cherry trees. They're very valuable, not only for their wood, but they're also very valuable for wildlife. This is showing a black cherry tree in bloom, very beautiful. And there are several things that help us identify a black cherry tree. The branch pattern is alternating, the leaf pattern is simple, the bark looks like burnt cornflakes. This is one of the few where the bark actually is probably the biggest clue to what the tree is. And obviously, the fruit, black cherries, is very helpful in identifying it as black cherry tree. So these are cold, hardy trees. They are present here at Eastman, but they're less common than other deciduous trees. They only account for about 2 to 6% of the trees here at Eastman. They can grow typically 60 to 80 feet tall, but they might grow as high as 120 feet tall and 1 to 3 feet in diameter. And their hard reddish wood is very valuable for furniture, for paneling, for some professional scientific instruments, for handles, interior trim, various toys, etc. And their branches and buds have an alternate pattern. And the bark of the black cherry is scaly and fissured and resembles burnt cornflakes. So some use the mnemonic BC, black cherry, burnt cornflakes. And I'll show you the bark in a minute. And there's an underbark that tends to have a bright orangish red color to it. And the leaves are oblong, finely serrated with long pointy tips and a tapering base. And in the spring, the leaves have a pair of brightly colored stipules, which are little outgrowths on the side of the leaf stalk. I'll show you a picture in a minute. And obviously, the fruit ripens in July and August when the green cherries start to turn red and then ultimately purple black at maturity during the fall. So again, they prefer moist soil, and so they need some slight shade in order for the seeds to germinate, but they're relatively shade intolerant. So they must have full sun in order for the seedlings to survive. And they're relatively fast growing trees, often averaging 18 inches of growth per year, and sometimes as much as 36 per year. So they're considered a pioneer species. And they may be susceptible to the eastern tent caterpillar, a common defoliating insect. And they're also susceptible to black knot fungus, but most trees don't actually die from that. They tend to have a shallow root system, so they're vulnerable to being blown down during severe windstorms or during hurricanes. So here's that bark that we talked about. So again, some people have said it recommends it looks like resembles burnt cornflakes. So again, that mnemonic BC, black cherry, burnt cornflakes. And then underneath the bark, if you were able to remove a little bark, you see a bright orange reddish underbark. The black cherry leaves, once again, are simple, they're oblong, they have a fine pointed tip and a tapering base. They have fine serrations, little teeth, very fine teeth. And then they have these rusty red hairs that tend to come off along the midriff of the underside. And in the spring, the leaves tend to have brightly colored stipules. That's these things here, which are outgrowths on either side of the leaf stalk. Black cherry blossoms come out in late spring. They're very beautiful. And the flowers are small, white, and arranged in terminal spikes that are about 5 inches long altogether. And obviously, the black cherries, the edible fruit, ripens in July and August. And each cherry is about a half an inch in diameter. They have a single round seed. And the green cherries turn dark red and then purple black at maturity in the fall. I like this picture because it shows the berries at several stages of ripening. You see a few green ones here, then they become a reddish color and ultimately become black cherries. So the black cherries make very good wines, jams, and jellies. And black cherry does have mast years every couple years, similar to the cyclical nature that we saw with the acorns and the beech nuts. So again, black cherries, again, they're very valuable to a number of wildlife species. The fallen cherries are important food sources for red fox, chipmunks, cottontails, white-footed mice, and gray and red squirrels. And black bears and raccoons may actually climb up into the black cherry trees to get to the fruit. And during winter, voles will feed on the bark at snow level, and white-tailed deer and moose will browse on the twigs. And many insects use black cherries as a source for food, particularly the leaves. And the nectar and pollen of the flowers will attract honeybees and bumblebees. And black cherry trees provide food for more than 200 species of butterfly and moth caterpillars. Some 70 species of birds actually feed on black cherry fruits and cherries. So it's an important food source also for wild turkeys and ruffed grouse in summer and fall. And birds may actually become intoxicated by slightly fermented cherries, and they fly into your windows. You probably all had a bird that was inebriated fly into one of your windows. And the fruit and seeds may also contain cyanide, which is toxic to ruminant livestock. Uh, we don't have any livestock here at Eastman, so that's not a problem for us. Birch trees are beautiful trees. Birch trees, there are more than 60 birch trees and 12 common ones. But we only have white and yellow birch here at Eastman. And the top showing white birch, also known as paper birch, and the bottom here is showing yellow birch. And birds are pioneer species, which means that they're rapid growing. They like sunlight, and they're species that will rapidly colonize an area that's recently been damaged by a natural disaster like a wildfire. So they are considered pioneer species. Again, one of the first tree species to grow after a wildfire or other disaster. They have relatively short lives, seldom living more than 70 years old. They're very shade intolerant. They need lots of sunlight. So we'll tend to see them along side open fields or alongside waterways or wetlands. And as the forest matures, they get choked out by the taller trees that block out the sunlight. And we have a rule of thumb. If you see one dead birch tree, look further into the forest and you're going to see many other dead birch trees. So they're somewhat unique in the way they drop their seeds. They tend to drop their seeds in winter, and those seeds are lightweight and wing-like, and they get blown across the top of the snow very widely. And because they lack shells, they tend to germinate early. So again, here showing these prominent horizontal markings on the birch, and the bark of the birch readily peels. And though there are more than 60 species of birch trees, we only have white and yellow birch here at Eastman. And once again, they are pioneer species. And again, the top showing white birch, the bottom showing yellow birch. Birch leaves, again, these are the leaves of the white birch or the paper birch. So they're somewhat almost heart-shaped. They tend to have these fine serrations. And the yellow birch tend to be a little bit more leathery, a little bit more elongated. And both have serrated edges, teeth-like structures on the edges of the leaf. But the birch leaves are narrower. The yellow birch leaves are narrower than the white birch. Birch polypore is a platform fungus that grows on birch trees. And it's often called tinder fungus because it has great utility in making fires. It has the birch polypore actually had three layers: a tough woody outer layer, a layer of tube-like pores, and in between those areas, a suede-like layer called the trauma layer. And once again, useful for making fires. Yellow birch is one of the dominant trees in northern hardwood forests, along with sugar maple and beech. And it's longer lived than most birch species, whereas most birch only last up to 70 years. Yellow birch can live up to 200 to 300 years and might grow to diameters as much as 4 feet in diameter. And it's the most shade tolerant of the birch trees. It does prefer cool, moist, nutrient-rich soils, so they tend to grow near eastern hemlocks, which also have those same requirements. And they tend to grow on root balls of fallen trees or in cracks and boulders and decaying stumps on logs. And because the seedlings can't pierce hard surfaces, including compacted leaf litter on the forest floor, they often spread literally on stumps or rocks, or then downward into the soil. About 1% of birch seeds successfully grow into seedlings, so only about 1% do that. And this is showing yellow birch. The bark tends to be shiny, yellow bronze, and it flakes or peels very easily in horizontal strips that you can peel off. And again, the leaves are oval with pointy tips, and they're doubly serrated, if you look at these. Birch seeds, which you're most likely to see in winter, are winged chimeras, and they're dispersed in autumn or in winter. So this is what they look like. We recently did a field trip in winter at the Marsh Billings National Park, and we saw many of these seedlings on the ground. So these are birch seeds. Once again, they tend to fall in winter. They get blown by the snow and disperse very widely. So the winter winds will disperse those seeds, scattering them across the snow. And they also are an important food source for many songbirds like chickadees and redpolls. Ruffed grouse and red squirrels will also consume many of these seeds. And as we mentioned before, because they can't penetrate the leaf litter, they tend to first land on things like mossy decaying logs and will tend to germinate from there. And then when that rotted log disappears, you're left with the stilt-like root system that's actually very prominent. So yellow birch are important with the ecology. Yellow birch are a food source for many species. Ruffed grouse and many songbirds will feed on the seeds and the buds. Yellow-bellied sapsuckers will drill holes and feed on the sap of the yellow birch. And many insects and caterpillars live on the yellow birch. White-tailed deer, moose, and cottontail will browse on the branches, and deer may eat the saplings. And the sap can be tapped as a syrup and may have a greater flow than that of a maple, but it has a much lower sugar content. Aspens often look like birch, but they're actually not birch trees. Aspens are often confused with birch trees. The birch bark peels off like paper, but the bark of aspen is smooth and does not peel. And when wind blows past their leaves and flat stems of aspen trees, they tend to shake like this, so they're often called quaking leaves. So aspens do resemble birch, but they're not birch. They're deciduous trees that are often interspersed with evergreens, and they often grow in clusters or clones. So you may come into an area that got multiple aspen trees. And aspens are considered a pioneer species in that they quickly colonize areas that have been recently burned or are otherwise bare because of natural disasters. They do need lots of sunlight, and they prefer moist soil. And we mentioned aspen leaves are heart-shaped and they tend to flutter in the wind. So if you're driving along the highway and you see something that's fluttering, those are probably aspen leaves. So they become a spectacular yellow in the fall, and they can be identified from afar by their quaking leaves. And aspens grow all the time. It's interesting. They're one of the few species that continue to grow even in wintertime. And that's because beneath the thin white outer layer, they have a thin green photosynthetic layer that allows the tree to create sugars and grow once the other deciduous trees have otherwise become dormant. So again, aspen leaves are somewhat heart-shaped and they're flat. They attach to the stalk through petioles that are flat, which allows them to quake or tremble in light breezes. And in the fall, they have this spectacular yellow color. And aspens do provide food for many animal species: moose, black bear, beaver, porcupine, ruffed grouse, and rodents. And beavers in particular are very fond of aspen trees, one of their favorite food sources. And again, because the aspens are still creating sugars and growing in the winter, Once the other deciduous trees have become dormant, the ground sugary layer provides necessary nutrients for deer and elk. One tree that didn't make our list of most common trees is the American basswood. We do have American basswood here at Eastman. They're also known as American lindens. And these tend to be very big trees with broad, rounded crown and characteristic big heart-shaped leaves. So it's a very good shade tree. And in addition to having the big leaves, they have red buds on their twigs that help identify them as basswoods. And the bark tends to have long, flat, rectangular ridges with narrow furrows. So you may see sprouts coming off the base. And the flowers, it does have flowers that grow in clusters in May or June. And those flowers are very fragrant and they're favorites of honeybees. And basswood honey has a very distinctive taste. And the heartwood is often subject to decay. So the older trees are likely to be hollow, and that provides cavities and good nesting locations for many wildlife species. So this is showing the leaves of an American basswood. They're big leaves. They tend to be 3 to 6 inches in length. Again, they are alternately arranged, somewhat heart-shaped, and very coarsely toothed. This is showing those buds I talked about. The twigs of an American basswood are very distinctive. They can either be light brown or even a reddish color, and the buds are actually red, bright red. So very few that show like that. This is the bark of the American basswood. It tends to have these long, rectangular shaped, flat, rectangular ridges with narrow furrows. And they are usually smooth, but they may become rougher. And again, as I mentioned, sometimes you'll see these shoots that are originally at the base of the basswood. The basswood does flower out in May or June. Here you see some of the flowers coming out. They tend to grow in long clusters. And the nectar is a favorite of honeybees. And as a result, this nectar has a very high sugar content, almost 33%. And it makes a very delicious, distinctive basswood honey. So that's deciduous trees. Now the conifers. Eastern white pine is one of the most common trees here at Eastman. And these iconic trees can grow well over 100 feet tall. And their straight trunks make them valuable for ship masts and poles. And they're the source for the green pollen that lands on just about everything in the spring and early summer. And many birds, particularly woodpeckers, turkeys, and also squirrels and even deer can eat the pine cones for their seeds. So eastern white pine can grow as high as 150 feet, and they usually tower over the other tree species, and their girth may be as much as 10 to 16 feet. So they're really big trees. This is showing the difference between white pine and red pine in terms of their needles. The needles of the white pine tend to occur in bundles of 5, whereas red pine tend to occur in bundles of 2. There's a difference between the bark. The top is showing white pine bark, and the bottom red pine bark, which tends to have more reddish tinges to it. If you look closely, you can see reddish tinge to this bark. Pine cones, when we talk about hard mast, we're usually talking about nuts like acorns and beech nuts. But in fact, pine cones are probably worth considering as hard mast. In reality, the pine cones should be considered hard masts. There are many birds and squirrels and even deer that do eat the pine cone for the seeds. And last year, we had a ton of pine cones. They were everywhere. So why did we have so many pine cones last year? Well, there was a bumper crop of pine cones in New Hampshire in 2024. I mentioned white pines do have mast years when a large number of pine cones are made, and most of those were present in 2024. 2023 was likely a best year for the pine cones. And as a result, all those pine cones you were seeing are female pine cones. They're the ones that produce the seeds. And the male pine cones are yellowish in color, and they grow in these little spike-like clusters that produce the pollen. And then they fall off the trees after pollination, which usually occurs in later May or June when we see lots of green pollen covering virtually everything. And squirrels and some birds will feed on those pine cones. And some birds' beaks are actually ideally suited for extracting the seeds from the pine cones. So, for instance, turkeys and quail readily seek and eat pine cone seeds. So, again, squirrels and some birds do feed on the pine cones. Some birds' beaks are ideally suited for attracting those seeds. We mentioned turkeys and quail. And red squirrels are particularly fond of the pine cone seeds, and they often stack high piles of pine cones. And in fact, a red squirrel once stashed 50 pounds of pine cones under the hood of a car. So this is showing pine cones. All the ones that you see on the ground are female pine cones. The male pine cones are these small yellow ones that tend to occur in clusters, and they're the ones that open up and actually release the pollen. So what's the value of pines for wildlife? Well, many birds, including woodpeckers and turkeys and crossbills, will eat the seeds. Squirrels and even deer will eat the seeds of pine cones. And deer, snowshoe hare, and other mammals will browse on the needles of white pines and bark. And beavers, porcupines, rabbits, and mice may consume the bark of pine trees. And their dense foliage and branches that are produced serve as nesting sites and roosting sites and provide shelter from predators. So they may provide habitat for cavity nesting wildlife. Certain birds, owls, and certain mammals are cavity nesters. And they allow shade-tolerant species to grow in their understory. And those may also have additional value for wildlife. So why are all those pine needles turning brown? Many of you have noticed this brown discoloration of the needles on many pine trees. Well, white pine needle blight is actually due to at least 4 fungal pathogens. And it happens after a period of heavy rain in the spring, followed by a dry period. But it's actually last year's rain that did this, not this year's rain. So again, white pine needle blight is caused by 4 fungal pathogens, and it follows wet weather in May, June, and July when the white pines are flushing out new growth, and it's followed by a dry season. And once again, it's last year's rain that triggered it, not this year's. And the condition has been increasing recently due to climate change, because with climate change, we've seen periods of increased precipitation followed by lengthy drought spells. And the trees are likely to fully recover, though if we have several consecutive years, that can lead to these pines actually dying. Eastern hemlock is actually the most common species that we see here at Eastman. Eastern hemlock is what's known as a foundation species, meaning that it has a tremendous impact on other species in an area. And these are the most shade-tolerant trees that we see here in the East, and they have very long lives. They're a late succession tree, meaning that as a forest is developing, they don't appear until later in the life of the forest. But they can grow up to 100 feet tall and 4 feet in diameter, though most are much smaller than that. And their branches produce a dense canopy that blocks all sunlight to the forest floor. So there are very few understory plants. And it's extremely important that those branches can intercept snow, so they make for very good deer yards. They protect the deer and multiple other species from big snowstorms. So eastern hemlock are late succession, shade-tolerant trees. Their dense canopy tends to block sunlight from getting to the forest floor. And they're a true foundation species because they influence a wide ecology, not only of plants, but also wildlife. Several things help us identify eastern hemlocks. They have two rows of soft, short, flattened, dark green needles on each side of its thin twigs. And the needles have blue-white undersides. And unique among these, they have stalked needles, meaning they have extremely short petioles. I'll show you a picture in a minute. And a distinctive feature of eastern hemlock is that they tend to be drooping or downsweeping nature, as opposed to spruce trees, which tend to go upward. The branches go upward. Hemlock trees tend to droop downward. And the branches do form a dense canopy that blocks the sunlight to the forest floor. So there are very few understory plants, and they tend to intercept the snow. So they make very, very good deer yards or areas for other species like turkeys to be in the wintertime. The cones are very small. They're only about 3/4 of an inch long. And hemlocks have a very high tannin content. So if they're near a stream, you'll see a dark red-brown discoloration to the stream. And the hemlocks also have relatively shallow root systems. So again, this is showing eastern hemlocks. Here are the needles. They're soft, they're flat, they're blunt. They're only about a half an inch long. And the needles are rounded at the tip, usually dark green above and pale silvery below. And in the spring, you may see these lime green tips on many of the hemlock branches. So again, the needles are short, they're flat, they're blunt, they're very flexible, about half an inch long. And the leaves stick up in the middle of the stem. They look like little ski jumps. These little things almost look like ski jumps. And the needles are rounded at the tip, dark green above and pale silvery below. And each individual needle is attached to the stem by a little wooden peg called a rachis. So these little pegs that are sticking out here. And once again, if you look at the underside of these, you'll see these two white lines, parallel white lines. See these here? And they're often called parallel racing stripes. And those model bands readily identify a tree as eastern hemlock. Eastern hemlock cones, again, are small, roughly 3/4 of an inch long, and they hang downward from the branches. That's important in distinguishing eastern hemlock from balsam fir. Balsam fir, the cones point upward, whereas in the hemlocks, the cones point downward. And red squirrels are particularly fond of these cones. So again, the bark of eastern hemlock is sort of a reddish purplish brown, and the furrows become more prominent as the tree ages. Hemlock is a foundation species, meaning that it defines the surrounding ecosystem. And because of that, any threats to the eastern hemlock, like the woolly adelgid, can have a much more widespread impact on the ecosystem. Years ago, 5,000 years ago, hemlocks were widely destroyed, perhaps by an insect or a pathogen, but they subsequently recovered. And in fact, it may have been actually related to climate change. Prolonged drought may have led to the widespread loss of the hemlocks. Eastern hemlock is very drought intolerant species. It has high moisture requirements, and it likes cool, moist, shady ravines. One area here at Eastman is the Catamount area, which has a very cool, moist, ravine-like area, and there are a ton of eastern hemlocks out there. So again, as a foundation species, it does influence the areas around them. So hemlock strands create microclimates with dense canopies that are producing shade, cooler soil temperatures, and a higher humidity, influencing what grows and survives in the understory. So sphagnum, mosses, and ferns often grow in the understory. And those shade-tolerant plants beneath them would die off if those hemlocks were not there. And it likes cool, moist, shaded ravines. And I mentioned the Catamount area of Eastman is just loaded with eastern hemlock. So if you step into a hemlock grove, you'll readily feel a drop in temperature and an increase in the moisture. So eastern hemlocks are very important for wildlife. Porcupines, especially, like hemlocks. And if you find many hemlock branches on the floor of the forest, that may be a good sign that there are porcupines nearby. Deer and moose will browse on porcupine branches, and those branches, buds, and bark that fall to the ground provide food for deer, snowshoe hares, rabbits, mice, grouse, porcupines, and probably others. Red squirrels are particularly fond of the of the hemlock cones. And hemlocks, I mentioned, do capture snow and block the wind, so it provides shelter for many species. And hemlock strands that reduce the snow depths and moderate the temperatures provide important deer wintering habitat. So we may find deer yards in areas that have lots of hemlocks. Many songbirds also breed in hemlocks, and the cavities that occur in hemlocks can provide shelter for a variety of species. They may cast a deep shade over streams, cooling the water so that cold water fish like brook trout can actually thrive. Hemlocks in the winter are blocking snow from falling to the ground, so that provides some shelter for deer, turkey, porcupines, and some other species. And they reduce the snow depth and moderate the temperature, so they can provide poor deer wintering habitat, and deer yards may occur in areas that have lots of hemlock. This is showing turkeys in the winter, which tend to forage by sacks in the winter. And again, they often roost in conifers that protect them from wind and other predators. Eastern hemlocks that are near streams, the hemlocks do cache a very deep shade, cooling the stream so that cold water fish like brook trout can thrive in streams that are near hemlocks. But the hemlocks also have a very high tannin content, so nearby streams will have a deep red brown color. Eastern hemlocks have that high tannin content, so hemlocks were used to tan leather, giving the leather a reddish brown color. And the wood has very little value as lumber, but sometimes it's used to make boxes or crates, and it can be used for pulp. Native Americans also made tea from hemlock needles. Apparently, it's very rich in vitamin C. There certainly is a threat to our hemlocks, and that's the hemlock woolly adelgid. This is an invasive insect that's threatening our hemlocks. It's a tiny insect that feeds on the sap of the hemlocks. They insert their straw-like mouthpart at the base of the hemlock needles and steal the nutrients that are needed by the needles, ultimately causing the needles to fall off. And the hemlocks don't die immediately, but they'll die if the infestation worsens. And the adelgids cover themselves in this white cottony substance, so it makes easy identification of infected trees. Spruce are another evergreen that has the familiar conical shape. Spruce grow relatively rapidly and can reach heights of 60 to 90 feet. And they may live 100 to 250 years or longer. And their needles are short, waxy, blue-green, and waxy. There are about 40 species of spruce trees, but red spruce is the most common that we see here at Eastman. This is showing spruce needles. They attach by these tiny peg-like structures called pulvini that occur on the branches. This is showing that the pulvini persist after the needles have fallen off. So the needles are rounded and the tips are sharp. And this is showing the difference between red spruce and balsam fir. Again, the needles here are much sharper in the red spruce than in the balsam fir. Spruces have square, four-sided, stiff needles that grow all the way around the flat twigs, so they're sharp and prickly. So if you see an evergreen, you can grab onto the needles, and if they're relatively sharp or prickly, it's probably spruce as opposed to hemlock or fir needles, which tend to be softer and flatter and can't be rolled between one's fingers. Spruce cones tend to grow hanging down toward the ground as opposed to hemlocks, or I'm sorry, balsam fir, where the cones tend to go upright. So the cones of spruce tend to be about 1.5 inches long. Here's red spruce. They can grow up to 75 feet tall and 1 to 2 feet in diameter, and they may live as long as 350 years. They tend to have shiny yellow-green needles that are four-sided. And again, this is showing the difference between the spruce and balsam fir. Spruce trees are more rounded compared to the more pointy fir trees that have a spire-like look. And spruce bark is plated, whereas fir bark is smoother, though it may have pitch pockets. Spruce needles are four-sided and they're pointy and sharp, whereas the fir needles are soft, flat, two-sided, and more flexible. Spruce needles attach to branches with a small stem, whereas fir needles attach directly to the branches. Spruce branches tend to curve down and then up, so they often have this kind of a unique thing. And again, spruce cones hang downward, whereas fir cones face upward. Red spruce do provide food and cover for various animals and birds. They provide winter cover for white-tailed deer. Red squirrels eat the buds and the seeds of the cones. Mice and voles will consume significant amounts of spruce seeds. And porcupines may feed on the bark of spruce in winter. And spruce do provide food and nesting sites for a number of birds. Balsam fir, on the other hand, is an evergreen that has a more pointed spire-like shape to it. And they can grow up to heights of 40 to 60 feet. And their diameter may be up 3 to 4 feet. Now, it's much more common for them to only be 1 to 1.5 feet in diameter. And the needles are flat, two-sided, and much softer, and they can't be rolled between one's fingers because they are flat. So the balsam fir is an evergreen with a more pointed spire-like shape to it. Very popular for Christmas trees, but those trees are usually grown on plantations rather than taken from the forest. And once again, they can grow up as high as 40 to 60 feet with a diameter of 3 to 4 feet, but much more likely to be smaller and be a diameter of maybe 1 to 1.5 feet. They're very shade tolerant and they tend to grow in cool climates with consistent moisture at their roots. Once again, their needles are flat, two-sided, and soft, and they cannot be rolled between one's fingers. And they do have two bright white bands on the underside. So the bark is thin and gray and smooth, and it has many pitch pockets, which are resin blisters. I'll show you a picture of those in a minute. And the cones are purplish, thumb-sized, and tend to point upward. And they're known for their aromatic, pleasant Christmas smell. So this is the bark of the balsam fir. It's smoother than that of most spruce trees, and it has these pitch pockets or these blisters which occur. And these blisters can actually be popped. You got to be careful not to get the resin in your eyes. The blisters contain a very sticky, fragrant liquid resin. Here are the cones of the balsam fir. They tend to have kind of a purplish color and they face upward. They may be 1.5 to 3 inches long, but very characteristic. So if the cones are purplish and face upright, you're dealing with balsam fir. And most seeds are dispersed by the wind, and small mammals may occasionally play a supplemental role by dispersing the seeds. The value of balsam fir for wildlife, uh, they tend to provide food and cover for various mammals and ferns. They provide shelter for white-tailed deer, moose, snowshoe hares, ruffed grouse, and other small mammals and songbirds. And its foliage is often browsed by moose and deer. And once again, the seeds are eaten by red squirrels, grouse, and pine mice. And the needles can also be eaten by some caterpillars. They actually play host to 114 species of moth and butterfly larvae. So we've done deciduous trees and conifers, but there might even be a few shrubs that may occasionally look like trees. Witch hazel is not a tree. It's a shrub native to the east coast of North America, but it can be confused with a tree if it's big enough, particularly when it retains its leaves in winter. Remember, we said trees that produce marcescens are oak, beech, witch hazel, hopthorn, and hopthorn beam. So witch hazel also has various skin benefits due to its anti-inflammatory and astringent properties, and it may help treat certain skin conditions that are due to inflammation. So witch hazel is available as a distilled clear liquid in most drugstores, and it's also an ingredient in various cosmetics and medications used to treat a whole bunch of different medical conditions. So again, it's not a tree, but it's a shrub. But if it's big enough, it may resemble a tree. And it's one of the few trees that keeps its leaves in winter, marcescens. So this is showing the leaves of witch hazel in the summer. This is showing it in the winter when it maintains its leaves. So witch hazel may grow as high as 30 feet, and its leaves are alternate oval, 5 to 15 centimeters long, and 2 to 10 centimeters wide, with a wavy sort of a margin. And it flowers in the fall simultaneously with maturing fruit from the previous year. And each flower has 4 slender strap-like petals that are 1 to 2 centimeters long. They're pale to dark yellow or orangish or red. And the fruit is a 2-part capsule, about a centimeter long, that has a single black seed in each of the 2 parts. And the capsule splits very explosively at the time of maturity in fall and ejects the seeds up to 12 to 40 feet, often with a very audible pop. So if you hear exploding or popping sounds in the fall, it may be witch hazel. And the leaves I mentioned may be retained in the winter, and that's called marcescens. And this is showing the witch hazel flowers. And again, the bottom is showing witch hazel leaves. And the other shrub that may occasionally grow big enough to be confused with a tree is serviceberry. So it can be large enough to actually be called a tree. Some people actually call it serviceberry trees. And early in spring, the blossoms will attract pollinators. So they often blossom earlier than many other plants in the springtime. And the berries ripen in June. They're very popular food for birds and some mammals. This is showing the serviceberries, and they can actually be an important food source. So it is a common shrub here. The shrub can grow up to 15 to 25 feet tall, and it might be spread as far as 14 feet wide. So some people call the large ones serviceberry trees. And it's one of the earliest blooming shrubs in spring, usually blooming in early April. And it's an essential early season food source for pollinators like bees and butterflies. And it can host larvae of several different butterfly species. And the berries ripen in June and are a favorite of songbirds as well as both large and small mammals. But deer, for unknown reasons, aren't interested in these berries. Very interesting. So again, the berries are often eaten by songbirds and some small mammals, but interestingly, deers ignore them for reasons that are unclear. One variety of service berry is known as autumn brilliance, and it's known for its brilliant colors in the fall. This is showing autumn brilliance. And an epilogue to this, note the pun, log, dead trees equal new life. Dead and dying trees help sustain life around them. More than 1,200 wildlife species actually rely on dead or dying trees, either for shelter or for food. Snags are dead trees that are still standing in the forest or in the wetland, and they're a great habitat for many birds and small mammals. And fallen trees become rotting logs that ultimately serve as food sources for many insect species. And mosses or fungi that grow on those logs are important parts of the food chain. Hollow logs can be great dens for many species. Moreover, they're an important role in storing carbon and recycling nutrients to the soil. And decaying trees provide natural protection and sustenance for young seedlings to sprout safely. And trees that fall into the water provide food, shelter, and habitat, not only for fish, but also for all sorts of wildlife. And among dead trees, allowing dead trees to decompose naturally extends carbon sequestration, and it's important in slowing climate change by keeping carbon dioxide levels down. So again, this is showing snags, basically dead trees that are left standing in the forest. They may actually make up as much as 10 to 20% of all trees that are present in some old growth, tropical, temperate, and boreal forests. And they're rich, support a rich community of decomposers like bacteria and fungi, insects, and other invertebrates. And the cavities that occur in snags produce great habitat for birds, bats, many small mammals, which in turn feed larger animal predators. And owls can have a great view from many snags. So again, there you have it. That's Trees of Eastman. Hopefully you've gotten some good out of this talk.